Hello everyone, this is DSS Zindabad and today we are going to discuss the Leetcode's daily challenge, which is range sum of a binary search tree. So the problem statement says that given the root node of a binary search tree and two integers low and high, return the sum of values of all nodes with a value in the inclusive range of low and high. So inclusive means both low and high are included, right? So before jumping into the approach, let's talk about what is a binary search tree. So a binary search tree is a binary tree in which the left subtree of a node contains only nodes with keys lesser than the node's value, and the right subtree would contain nodes with keys greater than the node's value, and both the left and the right subtree should be a binary search tree true. So now let's again use an example to quickly understand that which binary trees can be considered as binary search trees. So here, this is a tree that has been given to me, and let us assume 10 is the node, right? So everything on the left, that means the left subtree of this node will always be less than will always have values which are less than the roots node, right? The node's value. And similarly, everything on the right of it is greater than 10, as mentioned in the BST properties. Again, if I had a tree like 5, 8, 9, 6, 7. This is though a binary tree, but it is not a binary search tree because it does not follow the binary search tree properties, and this is a binary search tree. Now, why understanding the properties of binary search tree is important and why understanding the difference between binary tree and binary search tree was necessary is something you'll get to know in the further part of the video when we'll utilize it for improving the complexities. So now we've understood the basic concept of binary search tree. Now let's jump into the question. So basically the question is saying me that I am giving you a tree, I am giving you the value low and high, right? They are inclusive and you have to find me the sum of all of those nodes whose value lies in the range. So that means it is saying me something like what I can feel is it is very important that during the time of interview, you form a very constructive approach when you are targeting a question. You need to summarize your thoughts in a way so that the interview understands that how your thought process works. So what I'll say is we can simply begin with brute force. That means the first approach that is coming into my head. And like without considering of what would be the time complexity, what would be the space complexity, let's just jump into it. So my head says me that if I could travel all of these nodes one by one anyway, the traversal can be anyway. I'm not thinking about the traversal right now. I'm just saying that if I could go to every node, each and every node of the tree, and if I could figure out that, let us suppose this is X, right? So is it following this condition that is X greater than equal to low and less than equal to high? If this is true, right? In that case, I will have a sum variable. I'll just simply add the value of X in it, right? Else I can keep traversing. So this is a very simple approach that comes into my head. So now for solving this, as I'm talking about trees, we know that we have two types of traversals we can move forward with. So we can go for the depth first traversal or the breadth first traversal. Each of these traversals would lead us to the right answer. So here I will particularly demonstrate the depth first traversal using pre-order. Now what is pre-order? Pre-order states that we will be traversing in a fashion wherein we will visit root first, then left, and then right. You can use any of the DFS techniques, that is pre-order, post-order, or in order. And similarly, you can use the BFS. And for BFS, you can use the Q data structure. At the end of this dry run, I will show you the code for the same for both depth first search and breadth first search. So Let's quickly again make the tree here. This is the first example that has been given in the question on Leetcode. So here is the tree. Now I am saying I want to do two things, that is depth first search, pre-order. What is pre-order? I'm quickly writing it again so that we know how we're going to tackle this problem. This is the first thing. And the second thing that I know is that I need a value which lies in this range. So using these two properties, I'm going to solve this problem. So now what I'll do is I'll say I am on 10. First of all, create a variable sum. Initially it was 0. So I'll say, and obviously given this tree, I will also be given the low and high value. So in this case, I have 7 and 15. So 7 is low and 15 is high. So what I'll do is I'll say, okay, so right now I'm standing at the root, that is 10. Is 10 lying inside this range? I'll say, yes, it is. So add it. Now I'll move to the left part. I come here. So when I'm standing on 5, I see that it is not lying in this range. So I'll say, okay, don't worry. Go further left. I am following the pre-order. We'll say 3. 3 is not following, is not lying in this range. So I'll say, okay, because we do not have any children, so we'll simply return back. Now we'll come to 7. So 7 will say, yes, I am a part of it. We'll say, okay, the sum gets updated to 17. We move back. As we have traversed the whole left tree, we'll now traverse the right tree. I am on 15. Yes, 15 is a part. So we'll simply add it up. And that is 32. Yes, that is 32. And then what happens is we go on 18 and we say it is not the part of the range, so simply skip it. And eventually what we get is 32 as the answer. So this was a very, very easy approach that we had. So now quickly, let's look into what is the code for the DFS and the BFS using Q. So these are the codes provided for both of the approaches. This is the DFS code. This is the breadth first search code. We can simply see that here I created, first of all, I'm discussing the depth first search code. Here I've created a sum variable. I'm calling the pre-order function, and I'm simply traversing it and figuring out that if this is satisfied, then add it into the sum, and I'm returning the sum eventually. Now coming to the breadth first search code, here I have simply utilized a queue data structure. I am pushing everything into the queue and level wise, right? And I am trying to figure out that if this condition is getting satisfied, then put it into the sum and return me the sum. So now let's talk about the time complexity and the space complexity for both of these approaches. When we talk about the depth first search, the time complexity is O of n because we are simply traversing it, and the space complexity is O of h, which is the height of the binary search tree. For breadth first search, the time complexity is same, that is O of n, and the space complexity is O of w, that is the width at each level, because we're talking about level order, right? Okay. So now again, I said in the beginning that we will be using BST property. And you must be wondering that we have not utilized it yet. So what was the point? The point is, let's quickly take another example and try understanding why did I talk about that binary search tree properties. So the example is, I'll quickly draw the tree. And I'll tell you why is binary search tree property important in this question. Though the time complexity might not change a lot, but why the intuition behind it is important. So again, I will have something like sum. Sum is 0. I am following the order. Again, I'm using the DFS method pre-order, right? So root, left and right. And what I am checking, this was my first condition. My second condition was that x is less than equal to high and it is greater than equal to low. So what I'll do is I'm on, and for this question, I have my low as 6 and my high as 10, right? So quickly, what I'll say that yes, 10 is inclusive. Sum gets updated to 10. I come to 5. 5 is not inclusive, even though it is not inclusive. And I know that everything on the left of it would also not be inclusive. Why? Because they would be less than it. We just read that everything, that if this is a node, everything on the left would be less than the node's value, right? Though I know this, but I'll still go here because what? Because I am doing a DFS traversal. For me to return and go to the other side, I have to reach the end, right? So again, I'll go to 1, I'll say not included. Then I'll come back. I'll go to 7, I'll say now it is included. I'll go to 6, I'll say yes, it is included, right? So again, I'll go back here, right? Now I'll come here. Now it's a 15. I can clearly see that 15 is not inclusive in this range. So as it is not inclusive, anything which is its child would also not be included because of the binary search tree property. So this is the whole intuition of understanding the binary search tree property. And we can simply modify the DFS function a little bit and we can use this property. Now let's go to the code. So this is the code. I'm sorry. Yes. So this is the code, the modified DFS code in which I have utilized the BST property, right? And though the time complexity still remains O of n, but from an interview's perspective, it is very important for you to understand that why you were given a binary search tree. While you were given a binary search tree, are you utilizing its property or not, right? So here we have nothing, we've just done very simple changes that if the root value is less than low, right? That means it will never be a part. Simply skip it. If the root value is greater than high, it will never be a part. Simply skip it. Else we move into the simple DFS. So this was the approach. Thank you so much for viewing the video till the end. Please like, share and subscribe. Thank you so much.